Alright, so today we're going to be talking about a little story of something that happened between my sister and I here a couple weeks ago now. It's nothing like super important, but it's going to relate to my stories that I've been writing to physics and to me, I'm going to say taking for granted how much random shit I know, right? And forgetting that not everybody knows all this random inane bullshit, right? Um, so I guess let's get into it. Oh, there goes my cat. She doesn't like whenever I start talking sometimes. Okay, goodbye. Um, but so this happened a couple weeks ago where her and I get together every now and again, and she likes to talk to me about like the things that I'm writing. She actually like takes a lot of interest into it, right? And a lot of what I do with her is just explain parts of it, right? She wants to, well, she told me at one point in time that she wanted to like be my artist essentially. That hasn't really worked out, but that's besides the point. But either way, so I was talking to her about it, and and where we're at is I'm just kind of describing fundamental things about the entire world, the entire universe, everything that's going on, right? So we're starting at the very basics, right? And the basics is like, so there is five universes right now, like within my story universe or whatever you want to call it. Um, and I was describing the differences between each one. And as I was describing them, she was having trouble, I'm going to say, understanding the differences, right? So, I'm just gonna go through them kind of quick, willy nilly. So Universe Zero is just kind of like it's like our universe, but with no life, right? Universe One is exactly like our universe, right? And there is something else I'm gonna have to add on top of this. Universe Two, is exactly like our universe as it is, except for so the latent power that I have within my universe is that things can absorb. Well, that things can accumulate to essentially power themselves up. Now, instead of it behaving like our universe where gravity kind of controls everything, like everyone understands how gravity works, how the bigger something is, it'll attract things to it, right? Um, but in that universe, it is the amount of accumulated power that something has that causes that attraction, right? Um, and for the most part, in that universe, everything is the same until some sentient being starts, well, not even necessarily sentient, until something starts accumulating enough power to have this gravitational attraction to it. Then things start changing. That's where you can get like people becoming moons or people becoming planets or people essentially causing, planetary systems to orbit them, right? That's where you see actual gods come into being. Or things that people would worship, or you have stories or legends around these people who, became planets, these people who became moons, these legendary figures that no one knows how things actually work out. But she was having trouble understanding that. My brain. Universe 3 is hell. That is essentially just flat Earth but bigger, right? And it's supposed to be super simplified. So, and the entire reason for it is essentially so that different people in different universes can all come together. And it's because like the main, uh, they're called the creator gods, the original gods that have created everything, set everything in motion. These creator gods don't know anything, right? They are just trying to figure things out for themselves. So they wanted to know what would happen if these people and creatures from other universes start interacting with one another, right? Now, obviously, these people from other universes that are now on Hell interacting with each other don't realize that they're from different universes, but that's the entire thing that they're doing. And then Universe 4, um, what it is so I don't want to say it. Everything is like Universe 1, except for time is weird. To where it is essentially, think of it, the best way to think of it is through the metaphor, time flies whenever you're having fun. Take that, but make it literal. To where someone who is not paying attention to time, and if it feels like it is going faster, it will actually be going faster for them. So like they will physically age faster, and they will need to eat more often than other people. Such as if you just sit down and you're bored and you stare at a clock, you will live for hundreds of years because time is moving so slow for you. Um, but that's the entire thing. And she was having a lot of time or a lot of trouble uh figuring this out. Like it wasn't clicking with her. And I ended up having to ask the question. Now, the question that I asked was the wrong one, and I explained it kind of for the most part properly, but I attributed it to the wrong thing. I asked her if she knew what general relativity was, and I've now like I actually just went through and looked up a bunch of stuff here because I realized that I actually said the wrong thing to her. I'm gonna have to go and correct that at some point in time. But essentially, what I said, I essentially explained the four fundamental forces of the universe, and this is where we're gonna start talking about physics. The four fundamental forces of the universe, which is gravity, the strong force, the weak force, and electromagnetism. All right. Um, essentially, I needed to make sure that she knew what that stuff was because that's what I started messing with. And I'll explain briefly what each one is. Hopefully, I can remember because I just read them all. So, gravity is whenever you get things with certain mass, they will start attracting other things with mass to themselves equal to equal to how much mass each one has and the distance between the two of them, right? And then also something to note is gravity can only move as fast as light. Um, so like light speed is the top speed of anything in every universe. That is just kind of like a fundamental uh that is in general relativity, actually. That's just like kind of just how it goes. That is just the speed limit. So gravity also abides by that. Um, but that's what gravity is essentially just masses being attracted to one another. Electromagnetism, that's just think of magnets, right? It is anything that attracts something to something else. It is a bit more complicated than that, such as like electricity is also following the rules of electromagnetism. That's why current follows the way it does, is it's because the electrons that are moving are attracted to something else down the line. Then there's obviously, like I said, magnets, which are actually just oppositely charged particles being attracted to one another. So, like, if you charge like iron, right? If you give it a positive charge and then you take another piece of iron or another metal and give it a negative charge, that's what causes them to attract. And then, obviously, if you have two things with positive charges, they will repel. The same thing holds true in atoms, which electromagnetism is for the most part. Hold on, let me remember. No, that's the strong force. I'm sorry. The strong force is like electromagnetism, but on the subatomic scale. Actually, I think that they both do both, where electromagnetism is what causes electrons to be attracted to protons, but the strong force is what keeps nuclei together in an atom. I'm remembering here. So in an atom, I'm pretty sure everyone, well, most people have been taught, let me just look it up. Let me just look up the really simple atom. Fuck off. Okay. So let me just go ahead and pop this up here. Okay, and let me move this over here where you have these little circles, okay, so the protons and the neutrons here in the middle, where they're all kind of stuck together. The strong force is what keeps them together, and I'm pretty sure electromagnetism is what keeps the electrons near, like orbiting the protons and protons and neutrons. Um, and now the weak force is what causes so everyone knows the atoms, or hopefully everyone knows the atoms. The atoms are made up of electrons, protons, neutrons. right? Now, what a lot of people don't know is that there's something even smaller than protons, electrons, and neutrons, and they are called quarks. There is six different kinds. It is up, down, top, bottom, strange, and charm quarks. Um, and what keeps them together, such as I'm not entirely sure, but all of the examples I saw on Wikipedia whenever I was searching briefly is each one is made up of three quarks. Um, and those quarks, what keeps those quarks together is the weak force, right? Um, so and it's called the weak force because it is a weaker force than the strong force, which holds the nuclei together, which is weaker than the electromagnetic force, which is then weaker than gravity. But it's still all strong enough to hold everything together. And before anybody asks, quarks are as small as it goes. Quarks are not made up of anything. Um, and that's something else in my stories. That's something else that I didn't explain to her because I kind of forgot about this part of it all because it's been a while since I've looked into this stuff. Um, but in the stories, it would be quarks are made up of something called Zir, right? It's just this kind of it's like an enigma. It's almost like what people hear about dark matter in our reality universe. It's just kind of like a catch-all thing that just is anything we don't understand is either dark matter or dark energy. It's not so much dark matter anymore, it's dark energy whenever you start looking at this stuff. But either way, it's kind of like we don't understand this, so it's probably dark energy. Um, so essentially, it's the fundamental building block of everything is Zir, right? And as I was trying to explain how things work to my sister, it just wasn't clicking until I explained these things to her. And then she went, "Oh, okay, this is the basic building blocks." Now, I didn't go near as in depth with her, right? I didn't explain like the strong and the weak force. I didn't explain electromagnetism. Um, it was mostly just me explaining gravity and how because from universe 1 to 2 I'm messing with gravity and how gravity works because now instead of like I said gravity being attributed to mass, now it is how much Zir something is holding. um and then if you look at 4, uh how it works, because gravity also distorts time, now it would be Zir distorting time. The more Zir, well, actually no, it's still gravity. No, that's something that I actually still need to work on. I'm piecing it together, trying to remember if I worked that out. Is it Zir that distorts time? Because as perception warps, it would no longer be gravity distorting time. I'm gonna have to work on that. It almost have to be like time would have to be its own separate force in that universe. Um, that can then be manipulated by the perception of it. I think that that's how we're gonna have to do that. So, like in that universe, there'd be 5 different forces instead of gravity warping time. Um, it would just be its own thing. Okay. I'll have to think more about that to see the ramifications. But either way, that was kind of the story that I had with that and a science lesson on top of it. And also, like while I'm thinking about it and going on about it, it's I forget sometimes about how much knowledge I have because knowing these things about physics just honestly in day-to-day life doesn't matter, right? I take it for granted and I look into it and I find this stuff interesting and I consume a bunch of media and content on it, and like I go and read Wikipedia articles whenever I'm confused or I forgot something or if I just want to know something. And then I take it for granted, right? There's another time in my last job that I had to where I was kind of I was shadowing one of the techs, which are we did plastic mold what you call it injecting. Yeah, to where essentially just big machines just squeezed molten plastic into big steel molds, and then after however many seconds it would release it and dump them in. He was setting it up and he was explaining to me that the one press that so you need water to run through the molds to cool it down and make sure it stays at the right temperature. He said every time that the press started heating up, one of the tubes where the water went would just start spraying out water, and it would stop, but it always at the whenever it first started up, first started heating, it would do it, and it would just be a mess every single time. And I asked him, I'm all like, is it because of the pressure buildup? And he said, no, it's just because the water's getting too hot. And I had to sit there and I went, okay, hold on. Let me explain what I like, the reasoning for what I said. And then I had to explain to him essentially thermodynamics, right? So, in the tube where the water was, whenever the water was cold, uh, whenever you put the water through the tube, as much water as could fit into that tube would fill it up, and then there'd be no space left, right? And then how things work is whenever they're heated up, they actually expand, they get bigger because the particle or the atoms that it's made up of get excited and they start moving around and shaking, right? And that's why you get a solid block, right? And then whenever it gets so warm, they'll shake and then they'll start to move apart and now it's a liquid, right? And then whenever you keep heating it up more, they'll keep moving more and more and now it's a gas. And each time it takes up more space, right? Now inside this tube, there's the liquid, and even if it doesn't turn into a gas, because if there's too much pressure, things will not turn into a gas. They will not actually go from one stage of matter to the next if there's too much pressure. But I don't even know if yeah, it definitely did get hot enough to do that. But so while that cold water was in there, already the tube is at max capacity, and now it's getting hotter, so it's trying to expand. And now water, the way it behaves, is it will always take the path of least resistance. So unless things are absolutely sealed off airtight, which these tubes were, there was just kind of like a nozzle with ribs on it that you would shove into the tube just and it'd be hell to take it off. Always was hell to take it off if you needed to. But essentially, it's just that rib made it so it wouldn't come out. Well, water under that much pressure doesn't care. It'll push against everything, and then if it creates even a small gap, it'll start spraying out. So the cold water turned hot and expanded, but also you have to think about the fact that the tube, as it gets hot, it's made of rubber, will also expand. So now the tube that was originally this big is now this big, and the water that was originally this big is now this big, going through a smaller hole. So of course water is going to spray out, and once I explained all that to him, he's like, oh yeah, that makes a lot of sense. And I'm always like concerned whenever it comes to stuff like that because I've been called a know-it-all before, like many times, like derogatorily. And I don't mean to be a know-it-all, and I also don't ever want to be told that like I can never be wrong, cause I'm pretty sure I remember being told that too. And it's like I don't mean to never be wrong. I just know a lot, and then I explain it, right? And it's not that I'm trying to never be wrong. I'm just trying to teach people things. I'm just trying to make sure that everyone's on the same page, right? Because if I know something that you don't know and I realize that, as long as you're interested enough to not just not pay attention, I'm going to tell you it, right? It's not to make me seem smart or to make you seem dumb. It's so that you know more, right? And that's just my way of thinking. And I tend to explain and over explain and beat horses to death and then past death. Just because that's just how I'm wired. I like to teach people things. I will always like to teach people things. And that's part of why I learn so much. I like to know things and learn things. That way, if someone else needs that knowledge at some point in time, I can give it to them. Or I can find them the resources for them to have the knowledge that they want, right? And I don't know. I just value that and I like doing that. And I hope that I don't ever piss people off or step on people's toes by trying to help them, by trying to explain things to them. Uh, Now, I could definitely see myself being seen as annoying if because I do that a lot. And if they don't care, but I don't see that they don't care and they don't tell me and I just keep rambling on, I can see it being annoying, which I'm sorry, guys. I'm sorry if I'm annoying. But I think that's gonna do it all for this video. So, toodles.